Hi dear students, myself Deepak More and today I am going to teach you physics of standard 7, lesson number 6 and name of the lesson is sound. As we learned in the last video about the sound, how the sound is produced and we learned about sources of sound. Now today is the time to learn about sound needs a medium for propagation. As we learned that whenever a sound is produced, that time there is a formation of vibrations in that particular body. Then only there is a production of sound. Such way that only to flow of a sound from one place to another place, it needs a medium. It needs a medium. And to travel a sound waves from one place to another place, it needs a medium. So that only we will learn in this topic. As we know that sound cannot travel in a vacuum. That is why sound needs a medium for its propagation. So for that purpose, we will see a small experiment. So we will see that. Now we will see an experiment that will show how the sound needs a medium for its propagation. Though the experiment is as take an electric bell and an airtight glass jar connected to a vacuum pump. Suspend the electric bell inside the jar as shown in the picture. Connect the bell to a battery through a switch. On pressing the switch, the bell starts ringing and a sound is heard. The sound reaches us through the air in the jar. Now start the vacuum pump to withdraw the air from the jar. You will notice that as the sound jar is evacuated, the sound becomes feeble and feeble. After some time, when no air is left within the jar, no sound is heard. However, the hammer of the electric bell can be still seen striking the gong. The reason is that when no air is left in the jar, the sound does not reach us, although the bell is still ringing or vibrating. Thus, sound cannot travel through a vacuum. Though, as per the experiment, it is told that we have taken one bell and we have fixed that bell in a jar, and we have give a battery connection to it from the outside and tight the jar. As we will notice that whenever we will ring the bell, that time we can hear the sound whenever that bottle is containing the air in it. Now that bottle have a small hole from that the pipe is connected and that pipe is joined to the vacuum pump. Though whenever we started to remove the air which is present in the bottle, at that time again the bell were ringing. The bell were ringing. So as the air is going to be removed slowly, the sound of the bell is going to be feeble and feeble. At one time, whenever there is no air in the bottle, that time we cannot hear the sound. As we can see, the hammer of a bell is striking on a gong. It means that sound needs a medium for its propagations. And whenever air is present in our surrounding, that time we can hear each other's sound. So, do you know that in a space we cannot hear the sound of each other's if we are close to each other still, because there is no atmosphere present on the space or on the moon also. Now we will see next topic of the lesson, that is sound travels in the air in the form of longitudinal waves. So as we learn that sound needs a medium for propagation, so that's why the sound travels in the air in the form of longitudinal wave. Then how the sound is traveling in the air in the form of longitudinal waves, that we will learn in this particular topic. So whenever a sound is traveling from one place to another place, that time the energy of the molecules is going to be changed from kinetic energy to the potential, from potential energy to the kinetic energy. And whenever the molecules are going to change its energy, that time they are changing its energy at their mean position only. Means they are not leaving their position at any case. So they are vibrating at their mean position. So whenever they are vibrating at their mean position, because of their vibrations, the energy is transmitted from one molecule to the another molecule and another molecule to the another molecule. As the energy increases, the vibration of the molecules is increases, and it is going to be increase in a kinetic energy and decrease in a potential energy. Again, it is increase in a potential energy, decrease in a kinetic energy, and this is going on. And in these cases, the molecules are vibrating at their main positions, but the molecules are vibrating, and whenever they are vibrating, that time they are touching to each other. At that time, the sound is going to pass from one molecule to another, another to another, another to another, and this is where the sound is moved from one place to another place, and it will stop up to the sound will not hear to the ear. Otherwise, this process will be going on up to the place the sound will reach. Such a vibrations of a particle in the direction of a propagation is called as a longitudinal wave. Though we will see in detail about longitudinal waves. In a longitudinal wave, a point C on either side of which the particles of air move towards the point C is called compression, and the point R on either side of which particles of air move away from the point R is called refraction, as you can see in the given picture. The arrows in the diagram shows the direction of movement of air particles. One wave is from a compression to the next compression, or from a rarefaction to the next rarefaction. A longitudinal wave is graphically represented by the displacement distance graph, as you can see in the picture. This graph shows the displacement of particles of a medium at different distances at same time. Another way to represent a longitudinal wave is displacement time graph, which represents the displacement of particles of the medium with the time at a given position, as you can see in the given picture. The given picture shows that the displacement time graph in which time of one wave is represented by letter T, called time period of a wave. This is where the longitudinal wave we can show in a graph. Now the next topic of the lesson is some terms related to a wave. So we will see that. Now the next topic of the lesson is some terms related to a wave. So the first one is one vibration. So what is meant by one vibration? The to and fro motion which constitutes one full wave is called as a one vibration. The to and fro motion of a particular body which constituting one full wave is called as a one vibration. As in a given figure, a one full wave we can say that which is from one compression to the another compression, as I shown to you here, and which is from one rarefaction to the another rarefaction. We can say that that is a one wave. It means that one vibration means what? When there is a completion of full one wave, then there is we can say that there is one vibrations. Now we will see the next topic, that is the word of wavelength. So what is meant by wavelength, that also we will see. Now the next term is wavelength. So what is meant by wavelength, that we will see. The length of a wave corresponding to one vibration is known as its wavelength. Means the length of one wave it's corresponding to its one vibration, and it is known as its wavelength. Though it is represented by a lambda, symbol is lambda, and we can call it as a lambda. And it is given as lambda, and it is starting from one compression to another compression, or from one rarefaction to the another rarefaction. It means that the length of one wave or one vibration is called as a one wavelength. Is called as a wavelength, and always it is measured in a meter. It is measured in a meter. Now the next term is amplitude. So what is meant by amplitude? The maximum displacement of a wave on either side of its mean position is known as the amplitude. It is a maximum displacement of a wave the maximum displacement. This is a displacement graph to the distance, and it is a displacement means how much the height of the wave, that much more amplitude will be there upon that particular wave. So that is why the maximum displacement, it is a displacement, that's why as much more height upon wave, that much more amplitude. And it is represented by small a, as I shown here in the figure. By this arrow, this is the amplitude of that particular wave, and it is given as small a, and it is also measured in a meter. Now the next term is time period. So it is defined as the time taken by a wave to complete one vibration is known as its time period. It means that the time taken by an wave to complete one full vibration is called as a time period. As you can see in the figure, one wave is from one compression to the next compression, or from one wave fraction to the next wave fraction. It is nothing but one wave and one vibration, and that is nothing but a time period. It means that to complete and one full wave or to complete and one full vibration, how much time is taken is called as a time period, and it is always given as capital T, or always denoted as capital T, and it is measured in a second, because it is on a time. Now the next term is frequency, which is the last term. The number of vibrations produced by the source of sound wave in a 1 second is known as a frequency. What is meant by frequency? The number of vibrations produced by the source of sound. How many number of vibrations produced by the source of sound wave in a 1 second, is called its frequency. It means that how much number of vibrations produced as a source of sound wave in a 1 second, it is called as a frequency, and it is denoted by small f or small m, and the unit of frequency is hertz, which is symbolically is represented by capital H and small j together. This was about some terms related to wave. Now the next topic of the lesson is audible sound. There are some sounds that are audible to us and some sounds we cannot hear, which will be less or which will be greater. So we will discuss on it. Now the next topic of the lesson is audible sound. As we know that each vibrations are produces and sound, but we are the human beings. We cannot hear all the sounds. So we can hear the sound of the frequency range from 20 Hz to the 20,000 Hz. We can hear the sound of its frequency will be from 20 Hz to the 20,000 Hz. So we cannot hear the sound below the 20 Hz, and we cannot hear the sound above 20,000 Hz. And the range of the frequency from 20 Hz to 20,000 Hz is called as an audible sound. As I told you, each vibrations are producing this sound, but we are the human beings, we are not able to hear all types of sound. We can hear the sound of the frequency range from 20 Hz to 20,000 Hz, and we cannot hear the sound below the 20 Hz, and we cannot hear the sound above the 20,000 Hz. Now the next is ultrasonic sound. So what is meant by ultrasonic sound, that we will see, and who can hear the ultrasonic sound, that also we will see. Now the next topic of the lesson is ultrasonic sound. So what is meant by ultrasonic sound? The sound of frequency higher than 20,000 Hz are called ultrasonic sound, and we cannot hear the ultrasonic sound as we have the frequency up to 20 Hz to 20,000 Hz. So ultrasonic sound is a sound which have the frequency more than 20,000 Hz, that are called as ultrasonic sound. So who can hear the sound which is ultrasonic sound? The dogs The animals such as dogs, leopards, bats, monkeys, deers can hear the ultrasonic sound. The dogs can hear the sound which have the frequency up to 50,000 hertz, and the bats can hear the sound which have the frequency up to 1 lakh hertz. So how the ultrasonic sound is used by the bats, that we will see. As we are knowing about the bats cannot see at the daytime, but the bats, and we see that the bats are rarely moving at the daytime. But at night time, we see and we heard that the bats are moving very freely, as we cannot move in a dark place. They can move freely in a dark place. So how? But the bats can hear the sound, which is up to 1 lakh hertz, which one have the frequency up to 1 lakh hertz, and that is why they can move very free at night also. So we will discuss in brief. So whenever the bats are moving from one place to another place, that time their wings are making an ultrasonic waves, and that ultrasonic waves are passing front, forward rather than them. And whenever that ultrasonic waves are forward, as the position is back and the ultrasonic waves are forward, or it is far away from them, it is front or forward away from them. Then when the ultrasonic waves are not coming back, that time the waves are not coming back, when that wings are making the waves and that waves are not coming back to their ears, then the bats are moving very freely. But when there is an obstacle in between the way of the bats, and that waves are striking to that particular obstacle, that waves are coming back and that can hear by the bats. And whenever the bats are hearing that ultrasonic waves, that time the bats are changing their places, and this is how the bats are using the ultrasonic waves. Now the next topic of the lesson is infrasonic or subsonic sound. So what is the infrasonic or subsonic sound, that we will see. The next topic of the lesson is infrasonic or subsonic sound. So the subsonic sound or infrasonic sound is defined as the sound of frequency lower than 20 Hz are called as subsonic or infrasonic sound. And as we cannot hear the infrasonic or subsonic sound. For example, the pendulum of a wall clock makes an one vibrations in 2 seconds. It means that the frequency of sound produced due to their vibration is 0.5 Hz, and 0.5 Hz, it is a very less frequency, and that's why we cannot hear the sound which is produced by the pendulum which is present in the wall clock. Though in this new topics we learn about an ultrasonic sound, infrasonic sound, and audible sound. Audible sound we can hear, the human being can hear, and it is from 20 Hz to 20,000 Hz. And the ultrasonic sounds are about 20,000 Hz, and that we cannot hear. The human being we cannot hear. But the dogs, deers, bats, and leopards can hear the sound. And the dogs can hear the sound up to the frequency of 50,000 Hz, while the bats can hear the sound up to 1 lakh Hz. And about the infrasonic sounds are the sounds which are called as a subsonic sounds also, and which are having the frequency less than 20 Hz, and that is why we cannot hear the sound of infrasonic sound. From this all, we conclude that the ultrasonic sound and the infrasonic sound we cannot hear, while the audible range of the sound we can hear. And the speed of audible or inaudible or infrasonic or ultrasonic is same in the given medium. And the infant, a baby which is of 1 year old or less than 1 year old, that can hear the sound of frequency up to 35,000 Hz. And the limit of that baby is going to be decreased as the age is going to be increased. and the limit will grow up to the 20,000 hertz. Now the next topic of the lesson is characteristics of sound. So we'll see the characteristics of sound. There are two characteristics of sound, that are loudness and pitch. How these characteristics are based and how it is formed, that also we'll see. We'll discuss on it. As I told you, the characteristics of sound are two, loudness and pitch. And the sound is characterized on the basis of its amplitude and its frequency. And because of that, depending upon the amplitude and the frequency of that particular sound, we can distinguish or we can make a two characteristics about the sound, that are loudness and pitch. So we will see the first one, loudness. Now we will discuss about the loudness. The loudness of the sound is depend on its amplitude. It means that as much more the amplitude, that much more the loudness of that particular sound. Though the loudness of the sound depends on its amplitude of vibrations of the vibrating body produce the sound. And as I told you that as much more the amplitude of the vibrations, that much more the sound is produced. So we will see the diagrams, and by using that we will see how the amplitude will be more, then the loudness of the sound will be more, by using the examples. As we see the definition of the loudness, as much more the amplitude of the vibrations, that much more the loudness of that particular body will be there. So we will discuss by using these two figures, figure A and figure B, or wave A or wave B. In another wave A, as we can see that the wave is constant, but the displacement of a wave is less. And in another wave B, the wave B is also constant. The displacement of a wave B is more rather than wave A. And whenever we are comparing the wave, as the wave B is having more displacement rather than wave A, it means that the wave B is having more amplitude rather than wave A. That's why as much more the displacement, that much more amplitude, and as much more amplitude, that much more loudness. And that is why we can say that the wave B is having more loudness than the wave A, as the A2 means amplitude of the wave B is more than the amplitude of wave A. And this is how, where the amplitude or displacement of that particular wave is more, there the loudness of that particular body will be more. For example, we have to take an example then. If we pluck a string of a sitar gently, then we will listen the sound, but that will be a feeble sound. And if that same sitar we pluck the string hardly, then we will hear the sound of more. Then we will hear the sound more. It means that as much more we will stretch the sitar string, that much more the sound is produced. Again, if I have to give the example, then if we strike on the drum gently, then we will hear the sound, but the frequency or the loudness of the sound will be less. And if that same drum, the striker will be same, but only we struck the drum very hardly, then we will hear the sound of more frequency and loudness will be more. Now the loudness is depend on the area of the drum also. If there are two drums, one is having small size and one is of big size, the area of the drum will be less of one drum and the area of the another drum will be more. And we strike on both the drums same, We strike the board drum by using the same striker as well as the by using the same stick. We notice that the drum which one having more area, which is producing more sound, or the loudness of the sound which is produced by the sound which is produced by the drum which is having more area is more rather than the another drum which is having less area. So why? Because the vibrations which is produced in a drum which is having more area is vibrating for a longer time, and which have more area, that's why it is vibrating more. The distance of the vibration is more, while the drum which is having less area, that are vibrating for less time, and because of the area is less, that's why they are also vibrating, but the area is small, and that's why the sound produced by the drum which is having more area is more louder than the another drum which is having less area. This was it about the loudness. Now we will see about pitch. Now the next characteristics of sound is pitch. As the pitch of a sound is dependent on its frequency. The pitch of a sound is dependent on its frequency. Frequency means what? How much number of vibrations per second. It means that the number of vibrations produced per second by the body. Means as much more the number of vibrations produced by the body is more, that much more pitch will be there, and as much it will be less, that much less pitch will be there of that particular body. So like a sound of high frequency is said to have a higher pitch, while a sound of low frequency is said to have a low pitch. It means that the sound which one is having high frequency, that we can say has a higher pitch, while the sound which have the lower frequency, we can say that is having the low pitch. So we will discuss by using the figures. Now you can see the two figures as figure A, figure B. In a figure A, the graph is as displacement time graph. Figure B is also of displacement time graph. Only the difference is what? In a figure A, there is a 1.5 wave, and in a figure B, there is a more than a waves which are present in A. Though whenever we will see the figure, and as we will go on the definition of the pitch, as much more the frequency, that much more pitch. And if we see about the frequency says that as much more the number of vibrations, that much more the frequency. It means that as much more the waves will be there in a displacement time graph, as you can see that much more pitch of that particular sound will be more, and that is why the figure B is having more waves and more frequency. That's why the pitch of a figure B is more than the figure A, and the sound which have the more pitch, that we can say it is shriller than the sound which have the less pitch. And the sound which have the less or low pitch, we can say that sound is flat or grave. If we will discuss about it, then we can see that the girl's sounds and the boy's sound. The girl's sound is more shriller than the boy's, because the vibrations produced by the girls in our vocal cords is more than the boys. That's why the girl's sound is more shriller than the boy's sound. So this is for today. Have a good day. Bye dear students.